Hi children, hello, welcome to your home school. This is your class 9 mathematics NCERT or CBSE board, and we are in our chapter Polynomials exercise 4.4. Before starting this exercise, we need to start with a small tiny theorem, that is factor theorem. Let's see here. If p of x is a polynomial of degree n greater than or equal to 1. So what is this? Polynomial degree is 1 or greater than 1 and a is any real number, then if x minus a is a factor of p of x, if p of a is equal to 0. So what you can say children, if the polynomial in reminder theorem we have seen here, what is that? If p of x is a polynomial, let a be any real number. If you substitute a, you are going to get a remainder. Now that remainder, if it is a 0, then what you can say? Then x minus a is a factor of the polynomial, p of x is your first condition. Second condition, if p of a is 0, if x minus a is a factor of p of x. Either of the conditions are true children. Suppose if you have x minus a is a factor of p of x, then automatically p of a will be 0. If p of a is 0, then x minus a is a factor of polynomial p of x. So, I have showed you proof also here. Look here, proof by reminder theorem. Already we got that. What is that children? Reminder theorem. P of x is equal to x minus a into q of x plus r of x. R of x, what we have done? P of a is nothing but the remainder, right? In place of r, we have written p of a. Therefore, what I can say children? P of a is equal to 0 if p of x is equal to x minus a into q of x. When your remainder is 0, what happens? Then I can say that x minus a is a factor of p of x. Similarly, if x minus a is a factor of p of x, so what happens? X minus a is a factor of p of x. If it is what is the 0 of this children? X minus a, x equal to a. That a, if we substitute, what is happening here? A minus a into g of a. A minus a will be 0. 0 into anything will be 0. Then what you got here? Therefore, p of a is also 0. If x minus a factor, then p of a will be 0. If p of a is 0, then x minus a is a factor of p of x. Finally, what does this factor theorem say children? Your remainder. Suppose when you are dividing any polynomial with another polynomial, if you get a remainder 0, then the divisor what you are dividing is a factor of the polynomial. Okay? So this is your factor theorem. Based on this factor theorem, we are going to start our exercise. That is your exercise 4.4. Your first main, determine which of the following polynomials has x plus 1 a factor. So x plus 1 is a factor of these polynomials or not, you need to check. How can we check children? First sub question in it, x cube plus x square plus x plus 1. So let me assume this as polynomial of x. P of x is equal to x cube plus x square plus x plus 1. Okay. So what did they give you the factor x plus 1? Is it a factor or not? We need to check. So now let's find the 0. If x plus 1 equal to 0, x equal to minus 1. Send this 1 that side. What is the 0 of the given polynomial here? 0 of the polynomial. If you want, you can write here. 0 of the polynomial. 0 of the given polynomial. X plus 1 is equal to 0. And x is equal to minus 1. So now this x value, substitute in this children. Substitute x is equal to minus 1 in p of x. That means P of minus 1 is equal to minus 1 whole cube plus minus 1 whole square plus of minus 1 plus 1. Wherever you have x, put here minus 1. Minus 1, if you multiply 3 times, what happens? Minus into minus plus, plus into minus, it will be minus. That will be minus 1. Minus 1 if you multiply 2 times, plus 1. And this one minus 1 plus 1. Minus 1 plus 1, minus 1 plus 1 cancel. Finally, what you can get here, children? P of minus 1 equal to 0. Therefore, by factor theorem, what is the condition here? By factor theorem, by factor theorem, what you got here, children? P of A equal to 0. If P of A equal to 0, what you can say, children? Therefore, x plus 1 is a factor of the given polynomial. Therefore, x plus 1 is a factor of, what is the given polynomial? X cube plus x square plus x plus 1. Okay, if we get a 0 by factor theorem, I can say this is a factor of the given polynomial. Similarly, let's see the second one here. Same polynomial, we need to check for all the sub-questions. So what I can write here? Let us assume this as a polynomial. P of x is equal to x power 4 plus x cube plus x square plus x plus 1. Okay. What is the 0 of a polynomial? We have done in first question, children. You can repeat these 3 lines, these 4 lines here. So you can see now, these 4 lines you can repeat for every problem. So 0 of the polynomial, x plus 1 equal to 0, x equal to minus 1, substituting x equal to minus 1 in P of x. Now I am going to do here direct, children. P of minus 1 whole power 4 plus minus 1 whole cube plus minus 1 whole square minus 1 plus 1. That will be minus 1 if you multiply 4 times plus 1. Minus 1 multiplied for 3 times minus 1. Again plus 1 minus 1 plus 1. So these two cancel, you are left with 1. So finally what you can say, children? P of A is not equal to 0. Therefore, by factor theorem, P of A is not equal to 0. Therefore, what you can say? Therefore, x plus 1 is not a factor. X plus 1 is not a factor of the polynomial. That is x power 4 plus x cube plus x square plus x plus 1. Okay, easy now? Just substituting the value. Okay, see the next one. X power 4 plus 3x cube plus 3x square plus x plus 1. So that 3 or 4 lines continue here also. Let me write first with the polynomial P of x. X power 4 plus 3x cube plus 3x square plus x plus 1. And this arrow mark indicates that 4 lines you have to continue here. Now substitute minus 1 in x. Minus 1 whole power 4 plus 3 into minus 1 whole cube plus 3 into minus 1 whole square plus of minus 1 plus 1. Now this will be 1 and this will be minus 1 into 3 minus 3 plus 3 minus 1 plus 1. So observe here, minus 3 plus 3 minus 1 plus 1 cancel. You are left with 1. So 1 means what do you remember? By factor theorem. So by factor theorem, what you can say, children? By factor theorem, P of A is not equal to 0. Therefore, x plus 1 is not a factor of is not a factor of the polynomial x power 4 plus 3x cube plus 3x square plus x plus 1. Let's see the fourth sub-question in this. So here x cube minus x square minus of 2 plus root 2 into x plus root 2. Okay, so what we need to find first? Let us assume this with the p of x cube minus x square minus 2 plus root 2 x plus root 2. Same the 4 lines what we have done in our last 3 problems. No, you have to continue here and substitute x equal to minus 1. Then that will be minus 1 whole cube minus 1 whole square minus 2 plus root 2 into minus 1 plus root 2. Minus 1 if multiplied 3 times, minus 1. Minus 1 if multiplied 2 times, plus 1. And plus into minus, minus 1. Then here minus and this minus if you multiply, what happens? Plus sign you are going to get. So directly you can write 2 plus root 2. And now plus root 2. So now minus 1 will be minus 2 plus 2 plus root 2 plus root 2. Okay. So now again 2 and minus 2 will be cancelled. Root 2 plus root 2 will be 2 root 2. So finally what you can say here? Is this equal to 0? No. Therefore by factor theorem, P of A is not equal to 0. P of A means P of minus 1 is not equal to 0. Therefore, x plus 1 is not a factor of the given polynomial x cube minus x square minus of 2 plus root 2 into x plus root 2. Okay, it is not a factor. As we have done our first main, children, similar pattern, this is your second main. There we have a polynomial given, x minus 1 given. But now that polynomial we are giving with a g of x. Let's read the statement here. Use factor theorem to determine whether g of x is a factor of p of x in each of the following cases. Same manner, children, there before only x plus 1 given, now g of x is equal to x plus 1 given. Same manner, what we need to do, 0 of this polynomial. What is that? 0 of x plus 1. X plus 1 equal to 0, x equal to minus 1. Minus 1 is the 0 of the polynomial. That minus 1 substitute in this polynomial. If you get 0, then we can say g of x is a factor of p of x. If you won't get 0, then it is not a factor. Let's start. 0 of g of x, that is x plus 1 equal to 0, x is equal to minus 1. Substitute in p of x, that is p of minus 1 equal to 2 into minus 1 whole cube plus minus 1 whole square minus 2 into minus 1 minus 1. Same pattern, children, there is no change. Minus 1 whole cube, minus if you multiply 3 times it will be minus. So minus into 2, minus 2. And here it will be plus 1. Okay, and here minus into minus plus 2 into 1, 2, minus 1. Minus 1 plus 1. Minus 2 plus 2 cancel. You are going to left with 0. What you can say? Yes. If you get 0, yes. Therefore, by factor theorem, g of x is a factor of p of x. Right? Therefore, by factor theorem, theorem, by factor theorem, I can say that P of A is equal to 0. Therefore, G of X is a factor of P of X. Similarly, shall we do the second problem? Same manner. First, let's find the second problem. What is that? P of X equal to x cube plus 3x square plus 3x plus 1 and G of X is equal to x plus 2. First thing what we need to do? 0 of polynomial G of X. That is x plus 2 equal to 0. X is equal to minus 2. So now this minus 2 substitute here. P of minus 2 is equal to minus 2 whole cube plus 3 into minus 2 whole square plus 3 into minus 2 plus 1. Now minus 2 multiply 3 times. 2 2s are 4, 4 2s are 8. Minus 8 and this will be 2 2s are 4, 4 3s are 12 and minus 6 plus 1. So now, 8 plus 6, how much children it will be? 14. Same sign, right? I will write minus 14 plus 12 plus 1 will be 13. So what you are getting here? You are not getting 0. Therefore, P of A is not equal to 0. Therefore, by fundamental theorem, what you can say? Therefore, G of X is not a factor. G of X is not a factor of P of X. Okay. Similarly, you have one more sub question in this. Try to do that also as a homework, children. With this, we are going to end our session. In our next session, we are going to meet with your next main and we are going to complete that exercise. Okay. Thank you all.